My name is Vassilis Podamatas. I'm the project manager of Seamless. Professor Nikos Vendikos is the project coordinator of Seamless. Uh, I am currently part of the Maritime Risk Group, which is our research group within the National Technical University of Athens, one of the oldest and most renowned public universities in Athens. And today I'm going to take you through this introductory session relevant to the Seamless project. So first of all, a few facts about the project. What Seamless stands for is Seamless, Efficient and Autonomous, a multimodal library of European short sea and inland solution. Its duration is 48 months, so it has started in January 2023 and it will end in December 2026. Its budget is approximately 15 million and its consortium consists of partners from 12 different EU countries, 26 main beneficiaries and 9 affiliated entities. So what is the mission of Seamless? What Seamless is about? So the goal of Seamless is to develop a fully automated and economically viable waterborne freight feeder loop service in such a way that it ensures safe, resilient, efficient, and environmentally friendly operation in order to shift, road transport towards the waterborne transport. In order to achieve that, Seamless aims to develop what we call building blocks and enablers. Building blocks are mostly related to the development of technological innovation, whereas enablers mostly have to do with carrying out desktop studies, impact assessments, and developing roadmaps in order to circumvent and overcome real and perceived obstacles throughout the way. Now, the project's building blocks, there are three main building blocks, which again, they are technological innovation. First one is what we call dock and load, and it is related to port operations. So it has to do with developing a cargo handling solution that will be either highly automated or fully autonomous for containerized cargo. An autonomous mooring solution that is capable of utilizing legacy systems. It's capable of using bollards, albeit being autonomous. A software that takes care of the storage planning of autonomous systems, and sorry for that, and a software, what is being called in the project Autonomous Vessel Smart Port Manager, that is capable of handling port calls for autonomous system. So this is the first building block, what we call dock and load. The second one has to do with what we call the autonomy package in Seamless, so autonomous navigation, in particular low attention remote operation centers. The idea here is to go from a system where we have one operator being responsible for one ship, one-to-one operation, as we call it in Seamless or high attention mode, and take that and evolve it into one operator being responsible, operating and overseeing a fleet of vessels instead of one-to-one, which of course has the potential to unlock the full benefits of autonomy. The third building block is our logistics platform, what we call ModalNet. So what ModalNet can do is manage a loop service that goes from point A to point B and back, handle vessel scheduling, consignments, transport orders, and scheduling of events, and being able to offer alternative solutions in case a disruptive scenario takes place as well, through what we call the computational engine for resilient logistics. So these are the three main building blocks of seamless, and complementing that are the seamless enablers. What I previously mentioned, that they will be mainly desktop studies and impact assessment evaluations of the project. So we have broken this down into these four categories. First of all, regarding the regulatory framework, the project plans on identifying regulatory challenges as well as gaps. It aims to simplify the complex administrative procedures, complex compared to the road system, of course, that are currently ongoing in short sea shipping and inland waterways, and provide a roadmap and policy recommendations that will stem directly from the development of the seamless service. Now, regarding the ship and system design as well as the approval, Seamless also aims to contribute to that part as well through the development of a framework for assessing operational safety of autonomous port infrastructure, in particular dock and load, as well as developing an approach for selecting optimal power plant selection. And of course, one of the most important parts of this module here is the risk-based approval, which is essentially a simplification of the current MO of approving autonomous ships, which is case by case. And what we are all exploring is how we can make this simpler, faster, and this of course translates into being more economically viable for autonomous ships. Now, as I mentioned, we are also involved in assessing the impact of all of the seamless solution, and this mainly has two aspects, let's say it like that. First is the environmental impact of this developed service, and second is the social impact, which will be evaluated through a social acceptability study. Now, all of this, of course, in the end translates into producing viable business models. So in Seamless, not only we are going to do an EC approved cost benefit analysis, but we will also develop and describe the project's disruptive business models. Now, sorry, I want that. So a few words about the project's impact. So we have categorized it into three main pillars. First, the environmental pillar, Seamless, even though it does not explicitly develop any propulsive technologies, zero emission technologies. The service that we are describing, that we are developing, will be a zero emission service that will strive for the optimization of logistics with the aim of concretely contributing towards the net zero emission target of IMO and the European Commission, of course. Apart from that, the project's goal is to provide safe waterborne logistics as well as legal and regulatory services certainty. And on the business side of things, the goal is, of course, to do a model shift towards waterborne transport, develop disruptive business models, and reduce the risk for first movers. Now, here are a few targets of the projects. So first of all, to reduce cargo handling costs by 20%, try to make the investment cost of, a service, a waterborne service based on autonomous ships comparable to similar road systems. Of course, identify regulatory gaps and provide policy recommendations. Do work that is related to enhancing cyber threat catalogs, which is, of course, another very important aspect and very sensitive aspect of autonomous systems. Reduce time for administrative procedures by at least 60%. Through ModalNet, provide a secure modal dynamic management of the logistic network and carry out a techno-economic assessment of green configuration scenarios for autonomous ships. Now, apart from developing these technological building blocks and carrying out these desktop studies in our enablers, we also have a plethora of use cases in Seamless. 2 of them will actually be full-scale demonstration use cases, and 6 of them will be transferability use cases, which we will use in order to selectively use in order to determine which building blocks and which modules of the Seamless service are applicable throughout Europe, because we want to have as much as possible, of course, a pan-European impact. Now, this is a bird's eye view of the Seamless use cases. I will go through this very briefly because my good colleagues Anne-Sophie and Håvard will provide you a more detailed look. But in just a couple of words, is that the goal of the Seamless physical demos will be, of course, to verify and validate the functionality of our technology-oriented building blocks, and we aim to reach a target of minimum TRL 6. Now, the first physical demonstration will be in the Oslo Fjord, and in particular between Horten and Moss. The building blocks that we are going to demonstrate there will be the low attention operation of ships through the remote operation center developed by Kongsberg. There will also be a demonstration of the autonomous cargo handling module by MacGregor through a simulative environment, and the automated storage planning software that also MacGregor develops called VCOP. Last but not least, of course, there will also be a demonstration of our logistics planning platform, ModalNet, developed by Fundación Valencia Port. And the second physical demo of the projects, which currently what we have been discussing is to be between Dours through Lille all the way to Antwerp and from Antwerp to Duisburg. The building blocks that we plan on demonstrating there will be the autonomous mooring arm by MacGregor, the automated storage planning software, like I mentioned before, VCOP, also by MacGregor, and ModalNet by Valencia Port, and the software that is responsible for carrying out port calls for autonomous ships, called Autonomous Vessels Part Port Manager by Awake AI. Now, as a closing remark, what I would like you to keep from Seamless is that Seamless is mainly about providing a service, that optimizes logistics. And the way that Seamless does this is through automation. So Seamless contributes, in fact, to enabling the autonomous operation of ships by examining the autonomous vessel within its operational business contexts. For example, its interactions with other parts of the logistics chain. And as a result, it will ultimately lead to the development of new and disruptive business models that are, of course, crucial for the concept to work in actual practice. Yeah, and that was it from my side. Thank you all very much for the attention, and please feel free to ask away if you have any questions.
Yes, I think we have time for one question now, for one or two. I see there are some hands up. Um,
Yeah,
then if you want, please take it from here.
yeah.
Is there a question? No, it was just okay. It was just a reaction. So okay, if you have a question
Sorry.
on the road,
Yeah,
sorry, there's a
yeah.
hand.
Sorry, yeah. I'm not familiar with GoTo, so I was sorry. My
Please.
name is Jawad Tan. I'm a professor of ICT at the Delft University of Technology, and I'm participating in another project called BorderLink, which is much more focused on detection technology for customs for inland waterways.
Mm-hmm,
But one aspect there was that one use case we have there is on Hungary, in Hungary, on
mm-hmm,
with the Hungarian customs and the NSOE. So there is a whole that's a local network
mm-hmm,
to share data about event data, in particular event data. And I was wondering to what extent your solution, so this is an existing platform for Hungary for inland waterway
mm-hmm,
coordination. And I was wondering to what extent your solution is compatible or already tested with the existing data sharing systems. And the reason to mention in particular RSOE is that that will be tested with the CISE system, which is a European system for exchange of event data of inland waterways by European Commission. And that is in particular for risk data. So it's linked to the ICS2 and the like. So I was just wondering if you can reflect on that.
yeah. Thank you very much for the question, Professor. So, you are talking about data from our platform, from our logistics planning platform,
Yeah,
ModelNet. Is that right?
yeah, yeah.
Yeah, I'm not sure whether someone from Valencia port is here, but in
Yes,
case it's,
there's,
I can answer this, but
I, yeah.
But yeah, so I noticed if I'm not so you are from Greece.
yes.
Do you know so there's a Greek company actually involved doing building the connection between RSOE and CISE, and that is Setways. Perhaps
Hmm,
you know this. It's a software
hmm,
development company. Also, they have a platform.
yeah.
Are you familiar with this company?
Personally, I've heard of them.
Okay,
I don't have any
yeah,
connection with them direct,
okay,
any
but
contact.
yeah, otherwise it might still be interesting to that we keep in touch offline,
Yeah,
that we do it
yeah,
separately, and I will exchange some information about the borderless
absolutely.
project. Okay, thanks.
Yeah, yeah, thank you. And just to add to your question, that my understanding is that ModelNet and its exchange of information will be, uh, open and publicly available, and
Yeah,
follow the EFTI and
yeah,
federated data platform protocols. So, um,
okay.
yeah,
And we are doing the same because
okay.
I work a lot with the Port of Rotterdam, and
Hmm.
they have also very active interaction with the inland waterways, of course. And I had some contacts also Port of Valencia, because there were
Mm.
many projects where both Rotterdam and Valencia were involved.
Yeah.
And I know FT very well and Federated in
Yeah.
particular.
Yeah.
So
Yeah.
we will use parts of Federated, in particular the semantic model of Federated of
Mm.
Wout Wolfman.
Okay.
Okay,
Okay. Perfect.
interesting. Thanks. Yeah,
Thank you very
bye.
much, Professor. Yeah.